Today I am going to solve some numerical problems related to the chapter force, and it is especially related to the gravitation, gravity and acceleration due to gravity. Look at the numerical problem. Calculate the gravitational force in between two objects of mass 25 kg and 20 kg if the distance between them is 5 meters. It's a very simple numerical problem. For this, we have to write first the information given in the numerical problem. Mass of two bodies are given. One of them is of 25 kg. That's why mass of first body, which can be represented by m1 equal to 25 kg. And there is another mass also 20 kg. And that's why we can write mass of second body m2, which is equal to 20 kg. And they are separated by a distance 5 meter. That's why distance d equal to 5 meter. Okay, gravitational force is asked in the question. This is the question. Gravitational force is equal to what? Now the numerical problem written in the word is converted to mathematical form, but here one point is missing, that is gravitational constant. To solve this numerical problem, we are using this equation. M1 is given, M2 is given, D is given, and F is the question, but capital G is missing, that is gravitational constant. So we have to mention that here gravitational constant G equal to 6.67 into 10 to the power minus 11 Newton meter squared by kg square. Now we are going to solve the problem and using this equation. Look at, we have F equal to G m1 m2 by d square. Now we are going to write the value of capital G m1 m2 and d. Look at, this is 6.67 into 10 to the power minus 11 Newton meter square by kg square. This is the value of capital G, and m1 is 25 kg, m2 is 20 kg, and d is 5 meter, and d square means 5 meter square. It will be better to take the numbers together just like this: 6.67, 25 and 20. This way 6.67 into 25 into 20, and power of 10 later we can write 10 to the power minus 11. Now here we have kg square in denominator, and here kg and again kg in numerator, and we can cancel this, and remaining Newton meter square is written here. And in denominator there is 5 5s are 25 meter square. Number interacts with number, that's why these numbers are taken together. Now 6.67 into 25 into 20 gives 3335, and 10 to the power minus 11 remains same. And here again meter square is in numerator and it is in denominator also, that's why they cancel each other, and in denominator we have only 25. Now what we are going to do, this 3335 is divided by 25. Number interacts with number, and when we divide, then we will get this 133.4 into 10 to the power minus 11 Newton. Normally we do not express answer like this. Point is normally expressed after one digit. It means 1.334 into 10 to the power minus 11 we are going to write. And to shift this point to 2-digit left hand side, we have to multiply this with 100, because 2 digits shifted to left hand side. 100 means what? Multiplied by 100 means 10 to the power 2. That's why we can write this way: 1.334 into 10 to the power minus 11 into 10 square. It means we are multiplying with 100, and Newton remains same. Now next step, 1.334 remains same, 10 to the power minus 11 plus 2 Newton. If base is same, then power can be added or subtracted. Minus 11 plus 2, it means 1.334 into 10 to the power minus 9 is the final answer. We got the final answer, and we have to write one sentence for this answer. We can write this way: therefore gravitational force between them is 1.334 into 10 to the power minus 9 Newton. It will be better to write one sentence at the end. Okay, this numerical is finished. Now let's go to another numerical. Second, if mass of the sun is 2 into 10 to the power 30 kg and the earth is 6 into 10 to the power 24 kg and the distance between them is 1.5 into 10 to the power 11 meter, what is the gravitational force produced between them? And value of G is also given 6.67 into 10 to the power minus 11 Newton meter square by kg square. First we have to convert this numerical into the mathematical form. According to the given information, we can write mass of sun, which can be taken as m1, and it is 2 into 10 to the power 30 kg, and mass of earth, that can be taken as m2, which is equal to 6 into 10 to the power 24 kg, and distance is 1.5 into 10 to the power 11 meter. Another information is gravitational constant, that is 6.67 into 10 to the power minus 11 Newton meter square by kg square. And what the question? Question is, what is gravitational force? So gravitational force F equal to question mark. Now the given numerical problem is converted to mathematical form. We don't have to see the question now. We are using the same formula, F equal to G m1 m2 by d square. Look at this, F equal to G m1 m2 by d square. Now in place of G I am writing 6.67 into 10 to the power minus 11, and its unit also, and 2 into 10 to the power 30 kg, this is m1, and 6 into 10 to the power 24 kg, this is m2. Now d is left in denominator, 1.5 into 10 to the power 11 meter, and d square means whole square. Okay, now as we did in previous numerical, now we are taking all the numbers first, like this, 6.67 into 2 into 6 numbers are taken first, and then power of 10 to the power 11, 10 to the power 30, 10 to the power 24 is taken, and the unit kg square in denominator, and kg, 2 kgs are in numerator, and they cancel each other, only Newton per meter square is left. Now 1.5 into 10 to the power 11 meter square means we can write the same twice. Now let's go to another step. Now numbers, we are going to multiply these numbers with each other. 6.67 into 2 into 6, what it gives? 80.04, and 10 to the power minus 11, 30 and 24, the same base, that's why power can be added and added or subtracted. So 10 to the power minus 11 plus 30 plus 24, and meter square and this meter cancel each other, only Newton is left. In denominator we are going to multiply 1.5 with 1.5, it gives 2.25, and 10 to the power 11 and again 10 to the power 11 means same base, power is added, 11 plus 11. Now let's go to next step. We are going to divide this 80.04 by 2.25, because number interacts with number and power of 10 interacts with power of 10. So after the division of this 80.04 by 2.25, we'll get 35.57, and this 10 to the power 43 is left, minus 11 plus 30 plus 24 means 10 to the power 43, and in denominator 10 to the power 11 plus 11 is left, which is written as 10 to the power 22. Now next, 35.57 into 10 to the power 43, and 10 to the power 22 is positive in denominator. If it is taken to numerator, it becomes negative, and same base 10, so 43 minus 22 becomes what? 35.57 into 10 to the power 21 Newton. Here we have again problem. We are going to put this point after one digit here. That's why if we take this point to left hand side, one digit left hand side, then we have to multiply this number with 10. And so 10 means 10 to the power 1. So 35.557 into 10 into 21 means into 10 to the power 22 Newton. This way, lastly we got answer, and we have to write one sentence for our answer this way. Therefore gravitational force between the sun and the earth is 3.557 into 10 to the power 22 Newton. Okay, let's go to another numerical problem. Third, a man of 100 kg stands on the surface of the earth, which has 6 into 10 to the power 24 kg mass. This is the mass of earth. If the radius of earth is 6400 km, then calculate the gravitational force between them. Now we are writing all this information. First, mass of earth m1 is 6 into 10 to the power 24 kg, it is given here, and a man standing on it has mass 100 kilogram, it is written as m2. If the radius of the earth is 6400 kilometer, we are writing 6400 kilometer, but we are using SI system, so this kilometer should be converted into meter, and 1 kilometer contains 1000 meter. That's why I'm multiplying with 1000, and we are getting 64 having 50. It means point is at this position. We have to shift it to this position. I mean to say after one digit 6.4. So how many digit we have to shift it? 1 2 3 4 5 6. So point can be shifted from this position to left hand side. How many digits? 6 digits. So 6.4 into 10 to the power 6 meter is written here. Okay, now let's go to another point. Gravitational force F is the question. Now again here something is missing. What is that? That is gravitational constant, capital G, which is equal to 6.67 into 10 to the power minus 11 Newton meter square by kg square. Okay, now after this we can solve the numerical problem. We have this equation, F equal to G m1 m2 by r square. Why r? Because distance between the earth and a person is standing on it is the radius of the earth, center to center distance. That's why r. So we have to put the value 6.67 into 10 to the power minus 11. At this time I am not taking this unit. Better to not take these units, otherwise we may be confused. But if you want, you can take unit also. Again, m1 is 6 into 10 to the power 24 kilogram, m2 is 100 kilogram, and in denominator 6.4 into 10 to the power 6, that is the radius square. Now number interacts with number. That's why what we are going to do, this 6 into 6.67 gives 40.02, and this 10 to the power minus 11 plus 24, and this 100 is written as 10 square. Now in denominator we have to just 6.4 into 6.4 gives 40.96, and 10 to the power 6 square means what? 10 to the power 6 into 10 to the power 6. Now this number I am going to divide this number by this 40.96. So we'll get 0.97705, and remaining power of 10s are 10 to the power, here it is 13, 24 minus 11, and plus 2, again we have to add 2 because same base power we are going to add. In denominator we have just 10 to the power 6 into 10 to the power 6, that means 10 to the power 12. Now the power of 10 interacts with each other, that's why 0.97705 into 10 to the power 13 plus 2 becomes 15, and 10 to the power 12 in denominator, if taken to numerator, 10 to the power minus 12, and so we can write 15 minus 12. It means 0.97705 into 10 to the power 3. 10 to the power 3 means 1000. We can multiply this number with 1000 and we'll get 977.05 Newton. This is our final answer. That's why, therefore, the weight of 100 kg mass on the surface of the earth is 997.05 Newton. This is our final answer. Okay, let's go to numerical number 4. The mass and radius of Jupiter is 1.9 into 10 to the power 27 kg and 71 into 10 to the power 6 meter respectively. First is mass, second is radius. And find the acceleration due to gravity of it. It means the acceleration due to gravity on the surface of the Jupiter is asked. What will be the weight of an object having mass 75 kg on that planet? Here, another question is also asked, that is related to weight of a body of mass 75 kg. Okay, first we have to write the information. Mass of Jupiter, capital M, 1.9 into 10 to the power 27 kg. Radius of the Jupiter is r, 71 into 10 to the power 6 it is given. And another information, mass of the object 75 kg, and acceleration due to gravity we are going to calculate, and we have to calculate the weight of that person also. There are two questions. First we are going to calculate the acceleration due to gravity on the surface of the Jupiter, and when we get this acceleration due to gravity, I mean to say small g, then weight can be calculated, W equal to mg. Here one point is again missing, capital G. That's why I am writing here gravitational constant capital G equal to 6.67 into 10 power minus 11 Newton meter square by kg square. Now using this equation, what is it? Small g equal to capital G capital M by R square. Using this equation we can calculate small g. Capital G is 6.67 into 10 power minus 11 and mass of the Jupiter is 1.9 into 10 to the power 27, and there is R. R is how much? 71 into 10 power 6, and R square means 71 into 10 power 6 meter whole square. Okay, again we are doing the same thing. I mean to say number interacts with number. 6.67 into 1.9 and 10 to the power something, whatever given, should be taken together to avoid the confusion. That's why number into number and power of 10 into power of 10, and then we are writing unit. Okay, 71 into 10 power 6 whole square means 71 into 10 power 6, again we can write, and when we multiply 6.67 with 1.9, we will get this value, and power of 10 minus 11 plus 27, and in denominator 71 into 71 becomes 5041, and 10 to the power 6 plus again 10 to the power 6 gives 10 to the power 12. Meter square and meter square cancel each other. We are dividing 12.673 with 5041. And we'll get this number 0.002539, and power of 10 27 minus 11 gives 10 to the power 16, and in denominator we have only 10 to the power 12, and this meter square and meter square is cancelled. Newton per kg is left. Now again what we are going to do, when 10 to the power 12 is taken in numerator, then we can write this way minus, and 10 to the power 16 minus 12 becomes 10 to the power just 4. Again we have to multiply this number with 10 to the power 4. 10 to the power 4 means 1 having 4 0. It means 10,000. When this 10,000 multiplies this, then we'll get this value 25.14 meter per second square, and this is final answer. And therefore acceleration due to gravity is 25.14 meter per second square. Now let's go to another part of the question, that is weight of that object. Now the value of m is 75 kg and the value of g is 25.14 meter per second square. When we multiply these two numbers, we'll get 1885.5 kg meter per second square means Newton, and this is the weight of that 75 kg mass. Now lastly we are writing in sentence, therefore weight of the object on the surface of the planet is 1885.5 Newton. Okay, this is the solution of question number 4. Now let's go to question number 5. Mass of the earth is 6 into 10 power 24 kg and radius is 6400 kilometer. What will be the weight of the meteor having mass 1000 kg at the height 10 km from Earth's surface? Now it is meteor not on the surface of the earth, it is at the height of 10 km from the surface of the earth. We are writing given information, mass of earth capital M 6 into 10 power 24 kg, and mass of the meteor in comparison to the earth, meteor is very small and it is at certain height, it can be taken as small m, this is 1000 kilogram. Now other information, distance means height from the surface of the earth is 10 kilometer. Kilometer is converted into meter by multiplying it with 1000, because we are using SI system, and it becomes 10 to the power 4 because 1 having 40 means 10 to the power 4. Now other information, radius of the earth, which is represented as capital R, 6400 kilometer, and kilometer should be converted into meter. We are using SI system, and multiplying with 1000 we are converting it into meter, and it becomes 6.4 into 10 to the power 6 meter. Okay, now gravitational force F is the question. Now what we are going to do here, again gravitational constant is missing, that's why we are writing the value of gravitational constant. And then we have what? Capital G, capital M, small m upon r plus h whole square. The distance from center of the earth to the meteor is not only the radius of the earth plus height from the surface of the earth to the meteor. So we are writing now value. The value of G is 6.67 into 10 to the power minus 11. Capital M is 6 into 10 to the power 24. And small m is 1000 because 1000 kg is given as the mass of meteor. And capital R is 6.4 into 10 to the power 6. There is another matter also, the height. Height is 10 to the power 4 meter. When we multiply 6.67 with 6, we will get 40.02 and power of 10 are written. 10 to the power minus 11, 10 to the power 24 and 10 to the power 3. This is 1000 which is written as 10 to the power 3. Now in denominator we have a little problem. Here we have plus sign, that's why we have to solve them separately and we have to add them. Look at this, 6.4 into 10 to the power 6 means we are multiplying 6.4 with 1 having 60. We'll get this value. And 10 to the power 4 means 10,000. And when we add both of them in numerator, 10 to the power minus 11 plus 24 plus 3. Same base, that's why power are added or subtracted. In denominator we have different story, we have to add them. I mean to say these two values are added to each other and a square is written. Now again what we have, 10 to the power 16 in numerator, but in denominator we are going to write a little differently. Point is if shifted from this position to this position, then point goes to 6 digit left hand side, that's why 6.41 into 10 to the power 6 can be written, and here whole square is present previously. Now we have to solve denominator this way. When 6.41 is multiplied again with 6.41 because here we have a square, 41.0881, and 10 to the power 6 square means 10 to the power 12. Now we have to divide 40.02 with 41.0881. When we divide, we will get this number 0.974, and 10 to the power 12 is if taken to numerator, then it becomes negative, and 16 minus 12. 10 to the power 4 means 1 having 40, it means 10,000. When 0.974 is multiplied with 10,000, then we'll get the real number. This is the gravitational force between meteor and the earth. So we can write one sentence for this. Therefore weight of the meteor is 9,740 Newton. This is our final answer. Today we solved some numerical problem, and next class also we'll solve some other numerical problem.